Uncontrolled, unconfined fire is one of man's greatest enemies. In a confined space, the heat of combustion develops high pressure and temperature, which destroy life and property. Fire, controlled, can be man's friend and helper. Before man learned to control fire, he lived almost like other animals. After he found out the magic of fire, it became his servant to cook his food, heat his home, get metals from rocks, generate power, and many other useful purposes. Controlled combustion in a confined space generates power and does useful work. Without fire, our industrial civilization would not have developed. Coal would be useless. Many products come from coal: coke for steel making, drugs, cosmetics, and many chemicals. Another servant is natural gas. Gas joins coal to produce many synthetic products. Harnessed fire produces electric power. One cannot stop marveling at the wonders that man performs with electricity. Gasoline, another servant, is made to explode or burn. Not one drop is produced for cleaning purposes. Modern aircraft and automobiles are the results of manufacturing gasoline that explodes so well. The abuse of man's most useful servants makes the headlines. What is the magic of fire? Fascinating? Yes. Mysterious? No. To have fire, fuel is necessary. What is fuel? Primitive man burned wood for heating. When this stick of wood is held in a flame, it does not burn. Under such circumstances, wood is not a fuel. A paper card passed through flame does not ignite. So, the card is not a fuel. Over 100 years ago, the first oil well was drilled in Pennsylvania. They were seeking something to replace whale oil for illumination. Today, in refined form, it is known as kerosene. Is it a fuel? A burning match immersed in the kerosene does not ignite the liquid. Under such conditions, kerosene is not a fuel. If a petroleum-based solvent is desired to clean engine parts, Stoddard solvent, similar to kerosene, may be used. The same thing happens as with kerosene. Why won't the liquid burn? Isn't kerosene the fuel used in lanterns, stoves, and highway flares? Ah, but these have wicks. Let's take the same card that did not burn. Dip it in the solvent that did not burn. Now, the wet card just touches the flame and ignites. But the flame is extinguished when the card is immersed. Is this a trick? The card is not charred except on the edges. The liquid did not burn. What happened? The flame vaporized the film of liquid and the vapor burned, not the liquid or card. That being the case, the started solvent is heated to just above its flash point, the temperature at which enough flammable vapors are produced to maintain a flame. Here, liquefied petroleum gas, commonly referred to as LPG, is being loaded for transportation. It is an excellent fuel. The vapor from LPG is heavier than air, and if the supply line leaks, the vapor will travel with the air current and migrate to low places. A natural gas leak will produce opposite results. Being half as heavy as air, it will rise to high places. All types of gas appliances should be installed so that natural ventilation will carry away any unburned gas or products of combustion. Never use LPG in an appliance designed and approved for use with natural gas, or vice versa, unless the burners are changed in accordance with the manufacturer's recommendations. Approximately 3 times as much air is required to burn butane as natural gas. The temperature of this liquid is about 110 degrees Fahrenheit, a temperature that men prefer water for shaving. At this temperature, enough flammable vapors are given off for combustion. The lighted match hardly reaches the rim of the pan before the vapors ignite. The liquid does not burn, just the vapors. This establishes a fundamental fact. Fuel is necessary to start a fire, but it must be in the form of a vapor. Here's that same stick of wood which would not burn. Cut a few shavings on the edge, hold them in the fire, and they burst into flame. The solid wood is not burning. It is the alcohol, turpentine, and other flammable vapors that are given off when the shavings are heated. Many liquids give off vapors without heating. Common among these are ether, acetone, alcohol, and gasoline. Of these, gasoline is the most common. Here is an approved container for gasoline. It is made of metal, not glass or plastic. Glass containers break easily. Plastic ones may break, burn, or deteriorate. Most people would never put a flame to a safety can containing gasoline. But many think nothing of the far more dangerous practice of using gasoline to clean engine parts or clothes, or to remove wax from a floor. How close can a flame be brought to this pan of gasoline before it flashes? Again, the liquid does not burn, just the vapors. If gasoline is spilled, the liquid can be seen. The danger lies with the unseen vapors. Will flammable vapor alone burn? A spark plug is placed in the gasoline, but the spark does not ignite the liquid or the vapor. Fire does not occur until the spark is raised above the top of the jar. What was above the jar that was not inside? What was taken away when the cover was replaced? The answer to both questions is air, or more accurately, the oxygen in the air that combines with the vapor to form a flammable mixture which readily ignites. Here is plenty of vapor and air, but no fire. Here is plenty of gas and air, but no fire. To create fire, the remaining leg of the fire triangle is required: heat. The source of heat may be an arc, flame, hot wire, or a burning cigarette. When fuel is present in the form of vapor or gas, together with air and heat, a fire can be started. Having seen how fire is created, how can it be extinguished? The globe is filled with vaporized liquid petroleum gas. When the cork is removed, the gas, which is heavier than air, flows to the flame on the table. The flame travels up the tube and burns in an atmosphere of gas. This might be termed air burning in gas. And here is gas burning in air. Consider the principle of a flame arrestor. The screen lifts the flame away because the wires dissipate the heat required to ignite the gas under the screen. Raising the screen removes the heat leg of the fire triangle and extinguishes the fire. Replacing the cork in the tube cuts off the air and takes away the air leg of the fire triangle. To demonstrate the fuel leg, this equipment represents an approved storage container and a portable supply of flammable liquid. The bottle represents an underground tank at a gasoline service station. This vent extends from the tank to above the station buildings. Here is a tank truck. Gasoline starts flowing into the tank. Someone, ignoring the no smoking sign, ignites the vapors coming out around the truck filling hose or the vent. An alert station attendant or truck driver could close the tank valve, shutting off the fuel, removing the fuel leg of the fire triangle and extinguishing the fire. If any leg of the fire triangle is taken away, the fire goes out and the triangle collapses. This is an approved, sturdy metal container for storing flammable liquid. In case of fire, the lid opens to relieve pressure and closes to snuff out flame. Its low center of gravity makes it resist overturning. This plastic tube represents an empty container. Put in just a single drop of gasoline and allow it to vaporize. Adding heat through this spark plug completes the fire triangle. Nothing happens. Add a second drop of gasoline. Turn on the heat, and it explodes. Although the tube seemed virtually empty, there were just 2 tiny drops of gasoline. The 1-gallon approved container holds 155,000 drops, the energy of which is comparable to about 200 sticks of dynamite. Hardly anyone would store even 1 stick of dynamite in his basement or garage. Yet how many know of a gallon jug of gasoline stored around a home? The jug could easily break and the gasoline vaporize. Both dynamite and gasoline are made to explode, but the regulations that control the safe use of one are not the same as for the other. Frequently, laboratory and service station employees ask why they are forbidden to smoke, but are permitted to use an open flame on a bench or table. The top spark plug represents the bench, and when the plug is energized, no explosion occurs. But when the bottom plug, representing the floor, is energized, now 10 drops of gasoline are vaporized. no explosion occurs. Let's be sure that this is an empty container. To produce a fire, fuel as a vapor, air, and heat are required. In the plastic tube, 1 drop of gasoline was not enough, and 10 drops were too much to cause an explosion. The fuel, therefore, must be mixed with air in definite proportions called flammable limits. Even after an explosion, it may not be safe to enter a building or tank that is not destroyed by the forces of the explosion. Nothing is added to the tube, but another explosion occurs. And another. This is not necessarily the last explosion that could be obtained. No person should enter a building or a tank after an explosion without first testing for the safety of the atmosphere. Sometimes workmen who should know better call oxygen air and attempt to substitute compressed oxygen for compressed air with disastrous results. The explosions so far were obtained from mixtures of gasoline and air. The difference with an explosion of gasoline and oxygen is evident. The same gas-air mixture that burns freely in air will explode in a confined space. To illustrate, the flame is blown out. Then an identical gas-air mixture is allowed to flow into this tube and is sealed in it. Here in the open, the mixture ignites without perceptible sound, but in a confined space, it burns with considerable noise. If a gas mixture will burn, it will also explode. When using a flammable spray, stay away from flame. This distance is too close because a serious fire might be started. Many pressurized sprays contain flammable substances, so before a lady sprays her hair, she should read the label on the can. If it says flammable, believe it. Don't smoke or be near flame when using a flammable spray. Vapors of gasoline, butane, and ether are heavier than air and will flow downhill to low places. To illustrate, after saturating a handful of cotton waste with gasoline, the waste is inserted in the top of an open trough, and the vapors flow down the trough to the flame. Also, the flame elongates until the vapors are within the flammable range. Then the flame travels up the trough and ignites the waste. Open flame was perhaps the first gas detector. It is a good detector, but using open flame to detect flammable gas is a very unsafe practice. In early days of coal mining, young sons of miners were employed to watch the flame of a candle or open lamp, and when they saw it elongate, as shown here, they knew that gas was present and that something must be done to improve ventilation. The principle of the flame arrestor can be demonstrated again by placing this small mesh screen in a slot in the trough and another one over the top. The action of the vapors can be seen as they pass through the screen. The screen stops the flame by the same principle that it removed the flame from the top of the lantern globe. If one should be carrying an open container of flammable liquid and it catches fire, don't throw it. Don't drop it. Handle it as if it were the most precious article in the world. Put it down carefully to protect your life. As long as the liquid remains in the container, you know where it is. Many persons, including children, have been painfully burned, some fatally, from a dropped or thrown container of burning liquid. If a pan of grease on a stove catches fire, don't throw flour on it. Flour is combustible and will explode. Baking soda, put in a flour sifter and sprinkled over the fire, can be used safely as an extinguisher. A better method is to exclude the air by putting a lid or a wet cloth on the burning pan. Many disastrous fires and explosions are caused by careless smokers. Always obey no smoking signs. Extinguish all matches, cigars, cigarettes, and pipes before they are discarded. The magic of fire is intriguing, not sleight of hand or mysterious. Using fire improperly causes pain, disaster, and death. The magic of fire contributes to our comfort. It helps to create beauty, promote health, and provide many necessities and luxuries of our daily lives.